Alrighty. Nuclear power stations are one way in which energy can be generated without the use of fossil fuels. Well, there's still fossil fuels, by the way, involved in mining the ore and refining it, but largely without the use of fossil fuels. One example of a nuclear fission reaction is as shown. So uranium-235 eats a very slow neutron. We've slowed it down enough that it sticks to the nucleus and doesn't go right through it, right? Okay, so it creates these two nuclei plus some number of neutrons, right? So what you're going to do is you're going to balance this equation, right? So 235 equals 148 plus 85 plus x, right? Okay, so figure that out. Figure out what x is, right? I think I got the standard 3 neutrons that you should figure out yourself. And then, also, is it legitimate, right? Does this add up to 92? Of course it does, right? Okay, the following data are available, so they give you these masses, right? I don't know why they're rounding them so much, right? Determine an MEV, the energy release, so you know how to do that, right? Left side is going to be this plus this, right? 235.044 plus 1.009, right? Right side will be this plus 3 of those, right? That and 3 of those. Subtract the masses and find the mass defect, which I got the mass defect to be about 0.184. And then multiply that mass defect by 931.5. And you'll get something between 170 and 180 million electron volts. Okay. And then let's take a look at the next thing, right? So then it says, outline with reference to the speed of the neutrons, the role of a moderator in a nuclear reactor. Well, as the name implies, right, it moderates the speed, right? So basically the neutrons that are emitted in that reaction are fired off with sufficient kinetic energy that they don't interact strongly with the nucleus. They'll pass right through other nuclei and won't cause nuclear fission. Right, so what you do is you stick a moderator in here. I think they use like cadmium or something like that, right? This will slow them down, so they'll go from fast to slow. Well, slow neutrons are what you want for the reaction, right? So the neutrons are emitted at a high speed. High-speed neutrons don't cause reactions. So after they collide with the moderator, it slows them down. They lose kinetic energy, and then they'll cause more reactions, right? So that's kind of ironic, right? It seems if you slow down neutrons, you actually cause more reactions. But there it is, right? So moderator, yeah. Actually, I think cadmium is a control rod. That just absorbs the neutrons. You can use water as a moderator. You can use, if you want to live dangerously, you can use graphite as a moderator. That's what they'd used in Chernobyl. I wonder how that worked.